So my talk is titled, Oh No. And you'll see why it's titled that in a moment. Let's go with that. So this is heavily inspired by Gary Bernhardt's talk through Destroy All Software. It's a great site where you can see a lot of cool screencasts, and his is also under 5 minutes. So let's start by talking about C. Let's, what do we think this is going to print? Any ideas?
Trace.
Okay, prints 3, great. All right, let's declare an array, and we're going to get its 6th element, which is index through 5, 0 indexing. That's going to give you 0. But what about this? What does this give you? Does this even compile? It does, it's 0. Array indexing is commutative in C as well as most other languages based on it, because all this is syntactic sugar that dereferences a pointer and adds something. And addition is commutative, as we saw, so array indexing is. So, so there you go. That's the kind of theme of things you're going to be seeing, and it only gets weirder from here. All right, PHP. Woo! We love PHP. These strings equal? No, they're not equal. How about these strings? They are equal. How about these strings? They're also equal. PHP will do anything it can to treat anything you give it as a number. It doesn't care that you put quotes around those numbers. O1E4 is a number. It is 10,000. It doesn't care that you let it with a 0. It doesn't care at all. It wants numbers. PHP loves numbers. So, I mean, my God, it only gets worse. Now it's Java time. I love this one especially. All right, we're going to declare 2 integers. Cool. And as you expect, A is less than or equal to B. A is greater than or equal to B. Makes sense. A is equal to B is false. That's expected. These are objects. They don't actually point to the same value, even though they have the same value. You're actually declaring the objects here, therefore it's false. How about these ones? Okay. Less than or equal to, true. Greater than or equal to, true. Oh, look, these are true. So why when you compare these, are these true, and yet the other one isn't? So Java caches all integers between -128 and 128. Therefore, if you compare 2 integers that are between -128 and 128, they have the same value, that's true, whereas it's not true for numbers outside those bounds, which is a reason why pretty much every IDE, as well as I think a lot of Java compilers, will say, this is bad, you should not be doing this. You've made a serious mistake. And this is real, like this is how Java does it. It will literally cache that number because it leads to better performance at runtime. All right, so now we're gonna do probably my favorite one in here. So we're gonna make a nice little try block. Okay, so that's gonna return true, awesome. Now we have a finally block, and we're going to return false inside of that finally block. Those among you using exceptions should immediately feel very unsure, because you've probably thought, wait, can I even return anything inside a finally block? Well, in JavaScript, you get a syntax error for a return statement. What do we think we get in Java? You get a syntax error?
Return false.
In Java, we return false. And this is horrifying. Like, this is the worst possible thing. It should be illegal. It's illegal in a lot of languages, but both Java and C# say it's okay, which is absurd. Now, you can get this to happen in JavaScript, by the way. So we're going to say, we're going to declare value, make another block. We're going to return x. We're going to say x is equal to 3. And in JavaScript, that's 2. Because actually it's copied to the stack and we don't care that we made that modification. So that's bad. Oh no. And then finally, oh no, not quite yet. So Python, oh Python. I say 2.x because this is syntax error in 3.x, but you can say true equals false. Okay, now we're gonna say what true is. What's true? True is false. Is 1 equal to 1? Nah, it's still true. It should be double equals. But 1 is still true. But 1 equal to 1 is still true, even though true is now false. So that's great. Python's awesome. And then Ruby. Ruby lets you do things in places you should not be allowed to do things. So we're going to make a subclass. And this subclass is a subclass of any of these classes randomly picked. It picks one of them, and that's the subclass of it.
Rad.
All right. Okay.
Next
But
go to next slide.
okay, so you can have a random subclass, and at runtime, this could be any of them, and you have no idea which it is, because Ruby allows you to do that. And then finally, some great things in JavaScript. 1 multiplied by x, that's not a number, of course. X multiplied by 1, that's not a number, of course. X plus 1, x1. 10 dot toString, that's an error. 10 dot toString, nah, that's 10. What happens if you add 2 objects? Nah, it's not a number. What happens if you add 2 arrays? It should be what, like an array? Not empty string. What happens if you add an array and an object? Nah, that's an array of an object. What happens if you add an object and an array? Addition's commutative, right? Nah, it's 0. And then finally, does anyone know what this evaluates to? Yeah, it's 1. And that's it.